State the difference between scalar and vector quantities. Okay, so scalar and vector, what's the difference? Scalar has magnitude. Vector has? Okay, very good. So scalar are physical quantities with magnitude only. Okay, whereas vectors, they are physical quantities with magnitude and direction. It is optional for you to leave this out. Scalar quantities have magnitude only, while vector quantities have, yeah, okay, you can say both have magnitude and direction. Okay? You ever watch the, what's that show? Now next, state 3 examples of scalar quantities. There are a few. These are 3 examples that we have. If you have something that you would like me to confirm your answers, just let me know. Mass, yes, it is scalar. What else? Energy, also scalar. Any more? Volume. Okay, also can. Yes, please mark. We'll do your corrections. What else you want me to confirm with you? Any more? No? Okay. Then let's move on. 3 examples of vector quantities. Oops. Okay. These are the 3 that we have learned. Is there any else that you want me to confirm? Yes? Of course. Yes, it is a vector quantity. Any more? That you like me to confirm? Acceleration is already here. It is a vector quantity. Any more? No? Okay, next. Define distance. This is, yes? Of course, yes, we already said that it is also vector. Next one, you need to know point number 4. You need to be able to define all of them accurately during their exams. So this is a very important question. Distance. Total length traveled. Displacement. Okay. Length traveled in a specified direction. Write extra. What extra do you have? Was it from your notes? Oh, that's for distance. Okay, yeah, fine. But I tell you a secret, I don't think we will test you on definition of distance. But we'll test you for displacement, speed, velocity. Okay? But they may test you distance, I don't know. Yes? Straight line distance. Yes, okay. Can. Any more? Yes? No. Weight is temperature response. Yes? Yeah, can. Okay, next one, speed. Speed is simply the distance moved per unit time. As long as your answers, they were provided in your notes, it's okay. Do you have a textbook for science? Yes, you do. Yes, it is. So you can just refer to the section on physics for these answers also. And the next one, velocity. Rate of change of displacement. Okay, I don't like this definition over here. Let us just use the rate of change of displacement for velocity, yes? Yes, you can. Yes? No average. It cannot be average.
The rate of change.
You've done it already.
You've done it. Have you checked the answers already? Have you checked the answers?
Yes.
No? Okay, so please check it right now. 100 meters is actually 10,000 centimeters. Okay, what does the working look like? Doesn't have to be so long. Okay, in fact, for this question, we don't really need working also, because it's just straightforward. Okay? 250 seconds in minutes will be approximately 4.17 minutes. No, I said before, physics, no fraction. 3SF. Now that you have learned SF, I can use the word already. You have to leave it in 3SF. No, you want it. They already wrote down minute for you, right? And then how you put seconds? Convert it to purely minutes. So this one over here, if you are using this, you must have a bracket over here. I actually don't need to copy the whole thing. I got shorter working for you. Okay, so here 250 seconds in minutes. So we start with 60 seconds equals to 1 minute. So 250 seconds equals to 1 over 60 times 250. Then you get an answer. 25 divided by 6 is 4.166347. Rounded off to 4.17 seconds. Oh, sorry, minutes. Okay, this is my working. A bit shorter. And it is applicable for all these types of questions. Now, on 20 cm in meters, I'm sure you can do this. 0.2 meters, no need working for this one. 72,000 seconds into hours. Okay, so we know that there are 60 seconds in 1 minute, there are 60 minutes in 1 hour. So 60 times 60 is 3,600. Okay, are you able to do that mentally? 60 times 60? If you cannot use your calculator, so basically you get 3600. So 3600 second equals to 1 hour. So 72000 second must be 1 over 3600 times 72000. You should get 20 hours.
Well, you just take 72000 divided by 360.
Yes.
And you get the answer.
Next, 17 meters is 0.017 kilometers. 60 meters per second. Okay, this is the one that students might be confused with. So 60 meters per second is the same as 60 meters divided by 1 second. I want to convert it to kilometers per hour. You see that the numerator will always be distance, denominator will be time, right? So from meters to km, can you convert? I'm sure you can. Primary school kid also can convert. What is it? So what's the value? 60 to km. 60 meter to km. How much is that? Seriously, you all cannot convert? 0.06. Isn't it? 60 meters to kilometers. Okay, next 1 second to hour. So how much is that? 1 second to hour? 3,600 seconds in 1 hour, isn't it? Divide by 60. No, I want from second to hour. So it'll be 1 over 3600. Right? In working, can. But after that, your final answer, no fraction. So, calculator. I want all of you to practice using your calculator right now. I don't know whether you all even know how to use your calculator properly or not. So what's the value?
216 SB.
What's the value? 216. Anybody else got any other answers? Are you sure? So 216 is the answer. Anybody got any other answers for your calculator?
SB or
You can look over at your partner's calculator. Do they show you 216? Anybody do I have 216? Okay, then I trust that you know how to use it. So yes, the answer is 216 meters per, kilometers per hour. 216. Next. 100 minutes equals to how many hours? So 60 minutes equal 1 hour. 100 minutes equals to 1 over 60 times 100 equals to 5 over 3, which is 2.67 approximately. 1.67, sorry. 1.67. Okay, 3SF. 120 kilometers per hour. This one is slightly easier. 120 km divided by 1 hour. This is read as 120 kilometers per hour. So now I convert it to, what are the units that I want? Meter per second. Now easy to convert.
100 meters.
How many meters do I have over here?
120.
Meters, 1000. And number of seconds? 3600. So 1, 2, to give us 33.333, approximately 33.3 meters per second.
Huh?
Eh? 3.33. Wait, 1, 2, 0. Okay, the answer is 33.3, not 3.33. Okay, 33.3 meters per second. That's very fast. That is absolutely right. If you leave it in fraction, you will be deducted marks. Alright, question 6. Have we gone through this already?
No.
Did Mr. Singh go through this?
Yes.
Oh, homework, but got go through or not?
Yes.
Not yet. Okay, haven't go through. So now I go through. Calculate the length of the ship. The ship takes 5 seconds to pass a lighthouse. So let me draw the lighthouse over here. This is my lighthouse. And it takes 15 seconds to pass through. Okay, so 15 meters per second, it takes 5 seconds to completely move past. This is now my ship. Okay? So it's moving up. What time? When should I start timing? Here or here? 1 or 2? Both also can work. You tell me which one you want, 1 or 2. Who wants 1? Who wants 2? Okay, slightly more people want 2. Okay, so I start timing now. Okay, so it continues to move fast, right? When should I stop timing?
Yeah.
Let's stop now. Stop now? Yes, okay. So from this side to this side, how long did it take? 5 seconds. Okay. From here to here, it took 5 seconds. What is the speed? What is the speed? 15 meters per second. 1 second travel how far? 1 second travel how far? 15 meters, right? That is what 15 meters per second means. So if it took 5 seconds, then how far did it travel?
75.
So you need to use your mathematics from primary school. What's happening over there? There's something show? So it was traveling at 15 meters per second. Then when I start timing now, it took 5 seconds to cover this distance. Right? So what is the total distance traveled? How do you get 75? 15 times 5, you get 75. And what does that correspond to? Why should it correspond to the length of the ship? Because from the start, over here, this is the start. Then it started sailing until you get to this point. Time taken is the end. Time taken equals to 5 seconds. Speed equals to 15 meters per second. Distance traveled equals to 15 times 5, which is 75 meters. So from here to here, it travels 75 meters and then transfers to the length of the ship. That's how it works. The length of the ship. You just need to copy this part. Distance equals to speed times time. You get 15 times 5, you get 75 meters. When you look at your working, when you look at this working over here, just copying down the part circle in red. Next time, when you do a revision, you may not remember why. Okay, why is it that 15 times 5 gives me the answer? Then you go and watch the video again. Okay? Or you have to try and remember this logic over here on the board presented to you. Next, a car accelerates at a rate of 5 meters per square second from an initial speed. They ask you to do this question? Okay. Initial speed of 2 meters per second. Which one on the board is our initial speed? VU, TV or TU? U. U will be our initial speed. Then 10 seconds. What does this 10 represent on the board? Yeah, this is our TV minus TU. The V should be small at the bottom. So that is the final time minus the initial time. And that is given to be 10 seconds. Calculate the speed at the end of the 10 seconds. Now the speed at the end must be, which one? VU, TV or TU? V. This is V. Final speed. And then this must be our A. So which formula are we obviously using? Yeah, this one. Uniform acceleration. So A equals to V minus U over TV minus TU. Now I'm going to substitute in the values. Okay, how much is A? 5. Equals to, how much is V? Do I know how much is V? No, so we leave it as V. What is U? Divided by 10. Can you find V? How? Algebra. Did your teacher teach you already? What should we do? Cross multiply. Okay. So you are saying that you want to do this, is it? Then you want to take your pencil and you do this, yes? Oh, you don't need to write, okay? So it should give us 50 equals to V minus 2, yes? Then what is V? 50 plus 2, so 52 meters per second. Check. Yeah, correct. And you are expected to use algebra. Okay, so this is what I expect as our working. How many lines? One line, 2 lines, 3 lines, 4 lines. I don't need any extra stuff. But I also must see these 4 steps. Is there anybody who has what appears to be primary school maths in your worksheet? Or some guess and check, I don't know. Cannot, all not accepted. I only want something like this. If you are unsure, circle the question with a green pen, I will check. Next. A car traveling at an initial speed, 50 meters per second. Highlight initial speed. So what does this initial speed give us? U. Okay, so U equals to 50 meters per second. Comes to a complete stop in 5 seconds. What does this represent? T V minus TU. Yeah, but this is just information first. Now calculate the deceleration of the car. Wow, very tricky. deceleration. Did I give you a formula for deceleration? Are you sure it's the same? No, cannot be around that. Must be very certain. Same or different? Can I just take 1 more minute of your time? Let me just finish this question. Okay. Acceleration, Okay, negative acceleration equals to deceleration, right? Yeah. Okay, watch. This is very important, Deceleration equals to negative acceleration. So are they the same? I mean, acceleration and deceleration, are they the same? No, they are different. They are different with a negative sign.
Then T negative.
What is acceleration formula? So from this, can you now tell me the formula for deceleration?
V plus
Okay, negative v plus u divided by
negative ty. Wait, ty minus tu. On
this
top
is the formula for deceleration. All we need to do is multiply this negative sign to our numerator over here. Okay? This is not physics. This is maths. Which means if your maths is weak, you're going to face challenges in physics. Make sure you learn your maths well. So once I put it in the numerator, I leave my denominator as it is. So I will continue to substitute in values. What is the value of v? V. What is the
0,
value of v?
0 minus
0. Because it came to a complete stop. So v equals to 0. 0 plus u. What is the initial speed?
5.
What's the initial speed?
5.
Not 5.
Wait,
50 divided by time taken, tv minus tu,
5.
which is 5 seconds. So this gives me value? No, time taken, tv minus tu. So this gives me 10 meters per second squared. Look carefully at this. Okay, come. This is the part that many students are confused. This is deceleration, right? Deceleration is the same as negative acceleration. All of you are okay.
It's the opposite of
This one is just maths. I get this. I substitute it. Deceleration equal this equal 10. What is the deceleration? What is the deceleration? Is it 10 or negative 10? Very good. The deceleration is 10 meters per square second. What is the acceleration? Negative 10 what? Meters per square second. Not second square. Square second. Okay? So here, deceleration is 10 meters per square second, means it is slowing down. In the same way, we get negative acceleration, which is still 10 meters per square second. So we say acceleration is negative 10 meters per square second. So I know it is slowing down. This will be uploaded onto our Google Classroom.